My name is Lalith Liyanage. I'm very excited to present today's topic, climate change, what it means for water and wastewater infrastructure operators. This is the last webinar in the Valuing Water webinar series, a total of 6 webinars where WSP experts from around the world shared their lessons learned and their expertise to explore resilience in water and wastewater infrastructure. Before we start the presentation today, I would like to mention that PDF of this presentation is available in the handout box in the GoToWebinar platform for download. There will also be a question and answer period at the end of the presentations. Please feel free to write them in the question box as the questions comes to in your mind. This is the agenda for today that include an introduction with some basic definitions, anticipated key impacts on water and wastewater infrastructure, available responses, mainly focusing on operational, and then we will look at a sample project briefly, followed by a summary, and then going into our question and answer session. Global climate is a system consists of many components, including the oceans, lands, atmosphere, ice, and plants and animals. Key energy that drive this complex system is the sun. The overall effect at any given time within this system gives the global climate that include many parameters such as temperature, humidity, pressure, wind, precipitation, etc. Basically, the climate refers to that state of the system at any given time. Different organizations define climate change differently, but for the purpose of our water wastewater infrastructure assessment, we can select the definition given by the Intergovernmental Panel on Climate Change, IPCC. That basically saying that the statistically significant difference in mean properties of any of those climate elements that we talked about over a long period of time, usually a decade or longer. So let's talk with the climate change mitigation. Climate change mitigation means efforts to reduce or prevent emissions by means of utilizing new technologies, using renewable energy sources, and changing human behavior, etc. But we are not discussing that today. On the other hand, climate change adaptation means anticipating the effects of the climate change and taking appropriate actions to prevent or minimize the negative effects of those changes into the systems that we have. At the same time, maximizing potential beneficial effects of the climate change to the water and wastewater infrastructure. This graph shows the predicted temperature increases for Canada under A2 emission scenario, which assumes 15 billion of population by 2100 with heterogeneous development in and around the world. As you can see, by 2100, as per this model and this scenario, the global mean temperatures impact on the Canada will be close to 6 degrees higher than current levels. And that is a significant change for a climate system. If you wonder why with temperature, because it is an important measure of the climate system's health. Small change in temperature means so many potential effects. Generally called climate events, including melting ice, in some places flooding, droughts, and challenges and opportunities for plants, animals, including for humans. As I indicated in previous slide, these anticipated changes will have impacts on various aspects of climate and subsequently to various aspects of our lives. The overall impact list is very long. Here I have listed changes that may affect water and wastewater infrastructure. These are generally called climate events. Today, we are not going to discuss all these climate events. However, we will discuss some of these events later in our operational discussion. These climate events shown in the previous slide will have impacts on various areas associated with the water wastewater infrastructure, including the main infrastructure component itself. That includes the treatment facilities, collection system, distribution systems, and pump stations, for example. And in addition to the main infrastructure, support infrastructure will also be impacted, including buildings, warehouse, and other services. and including the administration too. Personnel, the facilities, equipment such as records also will be impacted. So a few areas that we need to consider when we are talking about the infrastructure impacts is the utilities. That's a very important component. Power sources, power lines, telephone, remote signals, for example, they all will have various impacts from these climate changes. Transportation, another important area, including vehicles, the roadway, and the access. So operation, today's focus will be the impacts of these climate events on the infrastructure operation. Many models predict effects on river flows. The main predictions include decline in mean annual river flow and higher spring flows and lower summer flows. This figure in the presentation shows the predicted flow changes in a few rivers around where I live relative to the historical mean. So if the historical mean indicated by the x-axis is 0 here, and this January, February, March into December, as you can see, in the future, it is predicted that in early springs, we will have significantly higher flows, up to about 50% higher flows, while in the summer months, June, July, August, we could have much less flow from the rivers. And this is very important because this is where we have the highest demand during the growing season and the drier and hot months. And that will generate significant problems and challenges to the infrastructure operation, which we will discuss later on. In addition to the rivers, the many models predicts effects on river flows. Groundwater will also be impacted, mainly due to high temperature and low recharge impacting the groundwater quality. Also, there will be a high demand for groundwater as a result of low summer river flows resulting from the low snow masses, for example, projected. Those wells that are recharged from snow will also be impacted. So the indirect demand will be increased due to the low stream flows during summer, longer growing season, and sustained drought. And people will turn more and more into the groundwater. So as a result, there will be high demand for groundwater sources. In addition to the above considerations, the other events such as prolonged droughts, flooding, the forest fires that we are predicted to happen more often, extreme weather events, prolonged growing season, algae, erosion, all of these factors will contribute to the general deterioration of water quality, impacting both water infrastructure as well as the wastewater infrastructure. Let's look at few specific impacts on major infrastructure components. The higher spring flows and low summer flows where the demand is high will not only impact required raw water storage size, but also filling strategy. High organic and high temperature will require more vigorous water quality control. Collection systems will experience higher odor and higher corrosion due to high wastewater temperature and also the high mineral content such as sulfur. Water distribution systems effects will include ecological changes within the distribution system, chlorine residual decay, because in warmer waters, chlorine decays faster. Water treatment operation will also have significant effects due to higher turbidity and higher organic content fluctuation. Generally, water treatment plants operate based on the seasonal raw water quality basis. Each season, we anticipate the changes and adjust the operation. However, when the seasons are unpredictable, operation becomes challenging. Wastewater treatment facilities also face challenges due to biological changes such as odor, corrosion, algae growth. In addition, if you have combined systems where both stormwater and wastewater is transported together, the systems may be overwhelmed due to high intensity events. Also, due to low stream flows, if you are discharging to a river, your impacts from your wastewater discharges will be much higher. This may demand alternative discharge operational strategies. Let's look at some of the responses available. There are many tools available to respond to the climate changes. The most appropriate tool depends on the specific conditions and the climate event and the type of asset you are considering. The available tools include insurance and legal measures. For example, in flooding prevention, in some cases, obtaining proper insurance and legal coverage may be much more beneficial than the actual design development. Policy changes, social measures such as education, behavior changes, public education, environmental, financial, such as compensation, and the technical solutions. So technical solutions can be categorized into both design or capital and operational. Today, obviously, we are going to talk focusing on the operational responses only. Some key example operational responses are shown here. This first column shows the infrastructure area, raw water storage, for example, and the second column shows the anticipated change. The first row, warm raw water, and the impact. The third column shows the impact. The fourth one, the required control, and the last column shows the some of the operational measures we can take. In case of the raw water storage, warm raw water and long summer will result in high algae growth. To control the algae, some of the operational measures that we can take include improved aeration and optimized chemical addition to control algae growth. And variable seasonal flows will result in unpredictable withdrawal window. If you have predictable seasons, we can withdraw in when the water quality is good, and then we can store to use when the water quality in the river is bad. However, with unpredictable seasonals, this manual predictable withdrawal will be challenging. As a result of that, operationally, we may have to include online analysis of raw water and also considering automatic withdrawal based on the river water quality. So the next one, we talked about the water treatment, anticipated change, warmer raw water, and the impact. Because of the higher temperature in the raw water, it will dissolve more minerals from the ground and on the soil, so resulting in high mineral content and high organic content as well. So the high mineral removal mean you require additional jar test as an operational measure and potentially higher chemical doses. And if you are utilizing filters to remove your particulate material, for example, more frequent backwash may be required. And warmer raw water means higher disinfection byproduct formation will also happen within the treatment plant. So to control disinfection byproduct formation, we may have to operationally to optimize the disinfection optimization by reducing the dose, for example, and even considering alternative disinfectants. As we may know, the monochloramine, for example, will result in much less amount of disinfection byproduct formation compared to the free chlorine, and reduce contact time. Those are some of the operational measures we can do to minimize the effect from these specific considerations. So if you look into the water distribution, again, warmer treated water will result in increased biofilm growth within the distribution system. And to control the biofilm within the distribution system, more frequent flushing may be required as an operational measure. And higher residual maintenance, maintaining higher disinfectant residual to control the biofilm growth, and alternative residual disinfectants that are more effective in controlling biofilm, such as monochloramine. And warmer treated water also will result in faster disinfectant residual decay. In couple with the higher potential biofilm growth, this may become a bigger challenge in the future. So to maintain the residual disinfection within the distribution system, operationally, we may have to maintain a faster recirculation in some areas within the distribution system, considering alternative disinfectants or having more backup chlorine feed locations within the distribution system. With respect to the wastewater collection, warmer raw wastewater will result in, again, high odor generation. So the odor control can be operationally dealt with by, for example, lowering the wet well retention time. That means the pumping from the waste to pump stations much more frequently at higher pumping rates, and also considering some chemical control measures to minimize the odor. Warmer raw wastewater also will result in higher corrosion. So the corrosion control measures will have to be taken, such as including chemical addition and minimize headspace, for example, within the pipelines. Within the wastewater treatment facility itself, the warmer wastewater will result in faster biological growth, particularly for wastewater treatment facilities that utilize biological treatment. The biological growth control will have to be implemented. Operationally, by reducing the solid retention time, we can control the growth of the biology to the beneficial bacteria and minimize the potential for growing the bad bacteria, I guess. So, and also another measure we can include is the increased food to microorganism ratio. Thereby, we can control the growth of the unwanted bacteria. Warmer raw wastewater can also result in denitrification in secondary clarifiers that will impact the effluent total suspended solids quality. To control the denitrification within the secondary clarifiers, operationally, we can operate the secondary clarifiers with higher hydraulic loading, for example, and maintaining low sludge blanket within the secondary clarifiers. So with that, now let's look at a sample study. York region is a municipality in southern Ontario with a population of about 1.1 million people. WSP's role on this project included analysis of historical climate data, identifying anticipated climate events, identify adaptation approaches, develop planning considerations, assess and qualify risks, and prioritize so that mitigation measures can be developed. Following that, recommendations made to change the design guidelines and a roadmap was developed for the region. This table shows the summary of the prioritization of various assets and climate events and the level of risk. As you can see, this is the different service areas that we looked at and different assets within each of the service area. And these are climate events. Depending on what climate event will have the higher impact on a particular asset, they were ordered in 1, 2, 3, 4, 5 in the order. And then these red colors indicated the higher risk of impacts on this particular asset from the climate event number 1. And the yellow shows the moderate amount of risk, and the gray shows the lower risk from that particular interactions from the climate event with that particular asset under considerations. And this created a very important roadmap or planning tool for the region, and then provided a good basis to develop a resilience roadmap for the region. In summary, climate change will have significant effects on all water and wastewater infrastructures. In addition to other adaptation measures, operational changes may also be required. Understanding the climate change effects on the water and wastewater chemistry and the water and wastewater biology is required to identify the appropriate operational changes. And with that, the operator training with the specific focus on climate change effects on water wastewater infrastructure operation will become critical in the future and is highly recommended. Thank you very much for attending the webinar today. Now I will invite Sharon to moderate the question and answer session.
Thank you, Lalith, for a fantastic presentation. Before moving into the Q&A period, I would like to remind attendees to enter a question in the question box on the GoToWebinar platform, and also you can download the PDF version of the presentation from the handout box on the dashboard. We will start with the first question. If I want to know what is the anticipated climate change for my region, do I have to conduct my own modeling, or are there places I can find this information?
Yeah, that's a very good question. Actually, there are lots of information available from various government and the non-governmental agencies for your region. I would highly recommend considering, research into that first. For example, in the case of the York project, the region of York project, the Pacific Climate Impact Consortium (PCIP), we were able to obtain a significant amount of data. And another agency that we contacted is the Canadian Center for Climate Modeling Analysis. And even the simple, the atlases, you can obtain significant amount of this information.
Thank you. We'll move to the next question. Having climate change adaptation plans for water and wastewater infrastructure, is it mandatory?
Yeah, that's again a very good question. And in our opinion, we think it's very critical and important to have such climate change adaptation plans specifically developed for the water wastewater infrastructure. Unfortunately, many jurisdictions, they are not mandatory as of yet, but it is possible that it may be mandatory in the future. Regardless for any region, because there are some other emergency planning processes are mandatory regulatory wise. However, climate change adaptation plans specifically look into the effect on water and wastewater infrastructure, and the other emergency planning processes are not actually considering those in detail. So we would highly recommend to have each community to have a climate change adaptation plan specifically developed for the water wastewater infrastructure.
Thank you. Next question. Do you have examples of quantifying the impacts of climate change on water, wastewater systems, monetizing the impact and prioritizing by highest potential damage?
Yes, I mean, even within the region of York, the project that we conducted, the objective is to quantify these effects so that we can actually develop we can quantify the risk and not only the effect and also the probability, and then you develop the risk score, and that's how you actually prioritize with the highest score. So the quantification of the impact for specific asset is required, and that's an exercise that should be done for the purpose of prioritization. So in essence, you consider a particular asset and you consider a particular climate event, and then you measure if that climate event interact and have an impact on that particular asset, what the damage will be. And then you have to quantify that damage, even monetize it, so that at the end you can have a score and then prioritize that particular climate impact.
Thank you. What tools can we use to address the interdependencies across the systems and cascading impacts?
Yeah, so when you're talking about different systems within the water wastewater infrastructure, I'm assuming that yeah, there will be cascading effects on some of the different components within the infrastructures. So it's again very similar to any other planning process. You have to basically starting from the high level or the first impact infrastructure, and then you can work toward the other ones, and then the quantifying the effects. If you're mitigating on one level, there will be a reduction in the impact on the second level, and so forth. So very similar to any other the planning process, actually.
Thank you. How does the emergency response plans related to climate change adaptation plans?
Yeah, that's a good question. Again, like an emergency response plan, the focus is different. That focus is to bring the systems back into operation as fast as possible, and those are usually impacts from the major events that go beyond the water wastewater infrastructure, and that include major hazards. However, the focus on the climate change adaptation plans are different, because the hazards that we are looking at are slowly happening for a long period of time. That's what we anticipate. So according to the responses and planning will be different, and compared to the emergency response plan, that will happen at any time and immediately, and then the objective is to bring the service back to normal, as opposed to a climate change adaptation plan. The objective is to increase the resilience of the water wastewater infrastructure, so that they will be more resilient.
Thank you. There is a question about clarification. What is denitrification?
Denitrification is the process where the nitrate and nitrite is converted into nitrogen gas by the bacterial process. what happened in the secondary clarifiers, if you allow warmer temperatures, obviously increase the bacterial activity faster. So previously you may not have a significant amount of the denitrification, thereby nitrogen gas bubbles are produced. But in warmer weather, you're going to generate more nitrogen gas. And what happens with that is that nitrogen bubbles will bring the particles to the clarifier and resulting or impacting the settlement. So therefore, you will have more solids coming out of the secondary clarifier, thereby impacting the water quality.
Thank you. There is a question here about scientific research. Maybe it's for follow-up after. Have you been able to find good scientific research on the impact to groundwater? There seems to be a bit of knowledge gap in the industry.
Yes, I mean, I would agree. I mean, there are some conflicting research as well, as any other field. Yeah, the impacts on the climate change impact on groundwater is generally lacking compared to the other research available for impact on the oceans and the surface water. And also the debate originally was whether there's an impact on the temperature impact at all, whether groundwater temperatures will be increased or not. But some of the recent research indicate that it is going to be impacting, and the groundwater temperatures will also be impacted. But I would agree that there's a shortage of research on the climate change effects on the groundwater. But as a general indication, we know if the predictions are correct and the groundwater temperatures increase, that will result in major issues because of the higher temperatures will dissolve more minerals, so it will be a high mineral content in the groundwater. If you have iron and manganese problem right now, it will be exacerbated. If you have a high solids, dissolved solids, it will be more. So the problems, current problem will be exacerbated if the groundwater temperature increased as some of the recent model predicted.
Thank you. We'll take the last question. How does the climate resilient related to adaptation plans?
Yeah, so yeah, the objective of the adaptation plan is to basically improve the resilience. I mean, resilience means the capacity of certain system to absorb the impacts from the climate change. So the objective of the climate change adaptation plan is to increase the resilience of the infrastructure to a sufficient level that the anticipated impacts will be absorbed without major impairment of the performance of the systems.
Perfect, thank you. So we're at the end of our webinar session. Please feel free to follow up directly with Lalith via the contact details shown on the screen. Thank you, Lalith, for a fantastic free presentation in the Valuing Water webinar series. It's been a pleasure working with you. And I would like to thank all attendees for joining today, and thank you, Lalith, for presenting today.
Yeah, thank you, Sharon. Thank you all for attending.
Thank you very much, everyone. I will wrap up the webinar now. Thank you.
Okay, thank you.